Okay, and Declan, is he with us? I'm looking for Declan and Dante. Okay, all right. So guys, were there any problems with yesterday's homework?
Maybe please just go over getting the inverse for A8.
A8. Okay, so just tell me on A8, sure. Okay, so it's exercise 2.5, everyone. Exercise 2.5, page 63. A8. Oh gosh, my pen won't work. Okay. So it's exercise 2.5, page 63. And we're looking at the graph of f of x equals 2 times a half to the x plus 1. All right, you had to draw that, but more importantly, you had to find its inverse. All right, so let's find its inverse. Remember, it's a reflection about the line y equals x. So if we find the inverse, this becomes x equals 2 times a half to the y plus 2. Wherever there's an x, you put a y, and wherever there's a y, you put an x. All right, now we have to solve for y. We have to make y the subject of the formula. So the first thing we're going to do is divide by 2. And that's going to equal a half to the y plus 2. Now remember what a log is. A log is an exponent. So this thing is in exponential form. And so that a lot of what we're going to do today is take it out of exponential form and put it in log form, or the other way around. So putting this into log form, you say the exponent, which is y plus 2, equals log. Your base is a half of x over 2. And so your y is going to equal log to the base a half of x over 2 minus 2. And that's going to be your inverse, written in that form. Log to the base a half of x minus 2. That's the log minus the number 2. Can you see that, Nick?
Thank you, ma'am.
Does that make sense?
Yes, ma'am. Thank you.
And that might be quite nasty to draw, but if you've drawn the exponential graph, which you've drawn in grade 11, that exponential graph you've drawn, the easiest way to draw this is to just reflect it. Just, take your 2 points and reflect them. All right, does anyone want me to draw them?
Yes, please, ma'am.
Okay.
Yes, please.
All right, so let's start with I'm going to do it on the side here. Let's start with the exponential graph. The first thing you really want to do is to find your y-intercept. So you make x equal to 0. All right, you make x equal to 0, and you're going to get a half to the 2. What's a half squared?
A quarter.
Quarter, and what's a quarter times 2?
A half.
Half. All right, so your y-intercept is at the point 0, a half. Okay, and now you need one other point. And as I said to you before, choose a good value. If I was you, I would choose something that is manageable. So I would choose x equals minus 1. Make an intelligent guess, but like your Newton's method. Let x be minus 1 as your other point. If x is minus 1, then minus 1 plus 2 is going to give you 1. And a half to the 1 is a half. And a half times 2 is 1. So if x is minus 1, your corresponding y value is going to be 1. Okay, and that's all you need for an exponential graph. And that's what it's going to look like. Okay, and that's all you need for f. Is everyone happy with that? Okay, Thomas, you here? Okay. Anyone got any questions about that one? Remember, you just need those 2 points. So you just need a y cut and you need one other point. And clearly this is going to be decreasing because look at your base. Your base was between 0 and 1. It's a decreasing function. All right, so now we're going to draw the inverse, the one that we've just found the equation for it. You don't have to put this line in. I just like it because it just gives me an idea of what I'm doing. So the point 0 to half becomes a half naught. And the point minus 1, 1 becomes 1 minus 1. They interchange. And so this graph is going to just look like that. And that's the inverse. So it is much easier to draw them if you draw the exponential graph, which you are familiar with, and then just swap your points. Okay. Everyone okay with that?
Yes, ma'am.
Okay, thanks for whoever's answering. I appreciate that. Okay, so that was 2.58. Anything else from the homework?
Sorry, just with regarding B6. So it goes log 2 to the x minus 1. Is that x minus 1 your number, or is it the log minus 1?
It's definitely the log to the base 2 of x. That's your log minus 1. So you're taking a log graph and moving it down 1. If it was going to be, so that's a really good question. Right, so this is B6. If it was log to the base 2 of x minus 1, then that's your number. That's how it would be written. It has to be in brackets. Okay, which is not. So this one said g of x equals log to the base 2 of x. So that's your log graph minus 1, means move the whole graph down 1 unit.
Okay, cool. Thank you, ma'am.
Do it, or are you happy with that? Because we know what subtracting a constant does to a graph. It just shifts the whole graph down by 1. Okay, so these mean different things, and it would have to be in a bracket if that was the number.
Yes, ma'am. Thank you.
Okay. Anything else?
Does the x minus 1 in the brackets, does that shift it 1 to the right?
Yes.
Okay.
Yeah. Okay. All right. So, yeah, if you're still doing them, you've got tomorrow in class and Friday in class. Remember, this test is on the Monday the 13th, so you've got time to ask me if you're working with logs. Okay, we're going to do some simple log equations today. So you can put a subheading, solving simple log equations. And they really are simple. We'll do some more fun ones in AP that are a little bit more interesting. But in core maths, they're fairly simple and straightforward. What you have to be able to do is be able to change something from log form to exponential form and vice versa. And secondly, you have to know your restrictions. So the things that we did yesterday. So if we can just go over that. If we've got log to the base a of x, okay, we know that your base, remember what we said about the base a, the base had to be positive and the base can never be 1. Your base cannot be 1. Then your number x, all right, x can only find the log of a positive number. So your number has to be positive. So in our log equations, depending on whether we're going to be finding the exponent, the base, or the number, we've got to be aware of and be mindful of the restrictions. So just to go through, the base has to be positive, never 1, and the number has to be positive, but the actual exponent or logarithm can be positive or negative, can be any real number. So just make sure you are aware of that and you've made a note on your restrictions. Okay, and one of the things we're going to do today is work out where we're going to use this in real life, because we're going to do some nice real life questions, and one that we're going to do quite soon, and it'll link to finance. Okay, can I take this away? Shout if I can't. Okay, so it's solving log equations, solving simple log equations. All right, let's start with the first one. The question will say solve for x. Just a very simple one. 2 to the x equals 3. Now, I don't know how far back you can remember, but in grade 10, when you drew your first exponential graph, or you were doing exponential equations, when you were faced with something like this, how did you do this in grade 10? How did you solve for an exponent where you couldn't get the same base on both sides? Does anyone remember?
Trial and error.
Trial and?
Just trial and error.
Use trial and error. And we would say to you, get it to as accurately as possible to 3 or 4 decimals. And you would sit on your calculator and you would do it by trial and error. Well, that no longer has to happen, because this is easy to solve when we have an exponential equation where the bases are different. Okay, this is just an exponential form, so we have to change it to log form, and we get that our exponent x is equal to log to the base 2 of the number 3, and that's in log form. And now you'll get out your Casio, and your Casio has a nice key. I'll put it under here. I don't know if you can see it. It's got a key that's logged to the base of something, of another thing. You can get that out, and the Casio will do the work for you. So if you take your Casio and put your base as 2 and your number of 3, you will get your answer. Let's do to 2 decimal places. And what is it?
1,58.
1,58.
Simple as that. Okay. Now you must be very grateful. In my day, we had to get out log books and all kinds of things. We didn't have Casios. All right, so that's really easy. So if we look at a similar second one, also solve for x. But we can make the exponent a little bit more interesting. Okay. Really common routine question in a paper. So it would be in section A, part A, solve for x. Same idea. You're never going to get base 7 written with base 5, so you're never going to get the same base on both sides. So you put it into log form. You take your exponent, and it log to the base 5 of 7. And then you add 1 to both sides. So it's log to the base 5 of 7 plus 1. And the answer for that, I have no idea what the answer is. What is it? Somebody?
2,21.
Okay. Okay, so that's finding your exponent. So I would like to just deviate for a moment here, because where are we going to use this? Where can you think we needed it? Where are we going to use this? Where could we not find the exponent in one of the sections that we did?
Finance.
Finance. Okay, in finance, when we had to find number of compounding periods. Okay, so in finance, when we had to find compounding periods, we couldn't. We had to do it either by trial and error. So now we've got a way of finding n. So if we just make up an example, I'm going to move this as our third one. So you can just relate it to finance, because you can see that's the first thing we're going to do in finance. We're going to say solve for n. And you would have something like 1,07, because that would be your interest rate, equals, I don't know, let's just say we've doubled our money. Okay, equals 2. So we're going to use it in finance. Okay, you can solve that for me, please.
Um, 10,24.
Okay, so n is going to equal log to the base 1,07 of 2, and the answer is 10, sorry, Nick, what was it?
24, ma'am.
4. Okay. So you can see why we need this and why we don't need it in too advanced in core maths, but one of its uses is finding n in finance. So that's quite useful. All right, let's go back to finding different parts of logarithms. So next one is solve for x, and it's log to the base 5 of x equals 2. So now you are finding a number, and now there are restrictions. And the restriction is that x must be positive. There are restrictions. So we're going to have to remember that at all stages, that in log equations, there are restrictions if you're finding the number or the base. All right, but we're still going to take it straight out of log form and put it into exponential form. And it would become?
5 squared equals x.
Okay, and you know it satisfies my restriction, and it's simple. So not difficult at all. Now, yesterday we found one with a base anyway when we were finding an equation. Okay, so we did that, no problem. Are you all right with this?
Yes, ma'am.
Okay, thanks. All right, so find for completeness, to find a base like we did yesterday in that equation we did in class. Okay. We have log to the base x of 4 equals 2. So now we're finding a base, and again there are restrictions. Our base has to be positive, and our base can't be 1. Okay. And once again, we take it out of log form and put it into exponential form. So it becomes base to the exponent equals 4. So x equals, theoretically, plus or minus 2, but x must be positive, so x equals 2 only. And we did that yesterday with our base of a third. That question was also solved for x. This one? Okay, 2 log x equals 8. Okay, 2 log x equals 8. Now we're going to look at this again in AP, this one, because there's a rule that we're going to learn, and I'm not going to tell you now, but next Friday we'll learn it. And then this problem, we have to, yeah, this can become, you've got to be careful on these, but for core maths, it's easy enough. Okay, if you get that, you're going to get log of x, if you isolate it, equals 4. Now remember what we said, our number has to be positive, so that's our restriction. What is our base here if the base is not written in?
10.
10, ma'am.
All right, so x equals base to the exponent. X equals 10,000, and it satisfies the equation. I mean, it satisfies the restriction. So luckily for core maths, the actual level of these is quite simple without any log laws. They will get more interesting in AP. That I can guarantee. Okay, so the exercise that I want you to work on now, and there is a little bit of time left. You can go and do it now. All right, it's page 68. It's exercise 2.8. And in A, I want the right-hand column. So it's 2, 4, 6, 8. 2, 4, 6, 8, 10. In B, I want the same, please. I'll just put a ditto. In C, if you could do 1 and 4, please. And the whole of D. And they should, I mean, these first few should take you at least 30 seconds each. They shouldn't be too difficult. And if you can do that, you do have a bit of time. We've used 25 minutes, so you've got 20 minutes. 10 minutes or what have you got? 10 minutes. Is that all right?
Thank you, ma'am.
Is that all
Thank
right?
you,
Who didn't come? Just before anyone goes, just hold on. Is Dante there? There are two not there. And Declan? No. Okay. All right. Thank you, guys. And I'll see you in class tomorrow. I think it's last lesson. Is that right?
Yeah.
Yeah. So any questions are for tomorrow and Friday, because first Monday back we start Euclidean geometry. Very short portion. Okay. And first Monday back we're back at school, so we at least can do some of the theorems at school, and then the riders while you're at home. Okay. All right. Thanks very much, everybody. Have a good day.
Thank you, ma'am.
Thank you, man. You too.
Thanks, ma'am.
Bye-bye.
Thank you, ma'am.
John,
ma'am.
can you stay or be gone?
Thank you,
already?
ma'am.
Who?
John,
Oh, yes, okay, ma'am.
if you can just say, it's just about your email last night. So I just want to chat to you. So, John, I'll certainly chat to Mr. Albertine, all right, about whether we can move the IT, the theory or the practice, because that will be his decision, okay, not mine.
Yeah.
And then the others, I'm not sure I can change. I'll look at it. I didn't look at it last night. Yesterday was a crazy day, but I'll look at it today. The thing is, it has to go out to the matrix before the end of the week. But I'll look and see, all right, if there is anything we can do to change it, if it at all possible. Okay. It has gone through all the HOSs and the heads of subject and everyone. So I'm making no promises, but I certainly will ask Mr. Albertine about the CAT and IT. Okay.
Thank you, ma'am.
Okay,
Thank you.
thanks very much. Have a good day. Okay, bye.